In this video, we are going to discuss about the topic called condition for symmetry and reciprocity for ABCD parameters. So for this one, we need to know the equations for ABCD parameter. So first one is V1, that is equal to A into V2 minus BI2. Likewise, I1 is equal to CV2 minus DI2. So we will equate this one. First step one is we need to find the expression. That is, first we have to connect V1 at one terminal and they have to short V2. Thereby, we need to find the current I2. Okay. So what is the step is to get the expression for the ratio of the response. Response means output, that is I2, and to the excitation. So excitation means it is the input. So here the input is V1. Okay, so at the input we are connecting V1, at the output we are connecting the I2. Okay, this is in terms of ABCD parameters. We have to connect V2 as a input, that is excitation, and we need to find the value of response as I1. Okay, so this is how the two-port network is. So for the first step, we need to connect V1, right? So this is a two-port network, and I have shorted V2 because we need to find I2, right? So here only it is I2. So in order to find the minus I2 value, so Y means the output flow from in this direction only. So here V2, so now the equations becomes V1 is equal to 0 into A, right, minus B into I2, right? So here instead of I2, I'm going to substitute minus I2, so that becomes plus B I2. Likewise, I1 is equal to 0 plus DI2. I can write I2 is equal I2 by, so B into I2 is equal to V1. So I2 is equal to I2 by V1 is equal to 1 by B. Okay. In similar way, I can write I1 by I2, that is equal to T. Okay. So we need to find the input as V1 and output as I2, right? So next step is we need to interchange the voltage and current. So here the input excitation is V1 and output response is I1, right? So we need to get the expression in the ratio of so it is output by input, then it is I1 by V1, right? V2. Okay. So for the ratio of excitation, okay. So but here I'm going to connect V2 as my excitation and I1 as my output. Okay. So for this one, the connection looks like this because since I1 we need to find, we need to short the input V1. Okay, because only one excitation should be there. So the V2 is there. And I need to find the value of minus I1, right? So if suppose the current I1 is flowing in this direction, means I need to find minus I1, right, in this direction only. So since I substitute in this equation, first equation, so 0 is equal to A V2 minus B I2. Next, instead of I1, I substitute minus I1. That is equal to CV2 minus TI2. So I need to find the value of in terms of V2 and I1, right? So what is I2 now? I2 is equal to A V2 divided by B. Okay, so substitute in the fourth equation. Okay. So if you see substitute in the equation, you'll get minus I1 is equal to CV2 minus D into A V2 divided by B. So from this you can find the value of, you can take the V2 common. So if I take V2 common, I will get C minus BC minus DA divided by B. Okay. So if I want to find the value of V2 by I1, what is V2 by I1? V2 by I1 is equal to AD minus BC, B divided by AD minus BC. Okay, so I'm going to equate this 7 with equation number that is I2 by V1 is equal to 1 by B. That is from the step 1. Okay, so for the condition for the symmetry and reciprocity is V1 is equal to V2 and I1 is equal to I2. Okay, so you can write V1 by I1 is equal to V2 by I2. Okay, so you can take these two equations, or you can take I2 is equal to I1, and therefore I1 is equal to V1 by B. So you substitute 8 in 9. Okay, if you substitute 8 in 9, V2 is equal to V2 B divided by V1 is equal to B divided by AD minus BC. So here V1 get cancelled out, BB get cancelled out. So AD minus BC is equal to 1. So this is the condition for reciprocity. Okay, so next we will go for how to find the values for symmetry. Okay, so for symmetry condition, here also V1 is equal to V2 and I1 is equal to I2. Okay, and from the Z parameter we know Z11 is equal to Z22. Okay, so what is the value of Z11? You should know. So what is Z11? Z11 is equal to V1 by I1 for the values of I2 is equal to 0. So first let me write the equation for ABCD parameter. So you know the values, right? Equation for ABCD parameter. So in this one, if I want to find the value of Z11, that is nothing but V1 by I1 for I2 is equal to 0. Okay, so substitute I2 is equal to 0 for both the equation. Right. So if we substitute the values of I2 is equal to 0 and in in the first and second equation, and you divide the whole term, that is first and the second equation. So you will get A V2 divided by C V2, that is nothing but A by C. Okay. So next, in order to get the value of Z22, what is Z22? Z22 is equal to V2 divided by I2 for I1 is equal to 0. Okay. So if substitute the values in 2, so 0 is equal to CV2 minus TI2. So what does CV2 is equal to DI2. Okay. So V2 is equal to V2 by I2 is equal to Z22, that is equal to D by C. Okay. So now you equate Z11 with Z22. That is a condition for symmetry. So A by C is equal to D by C. So A is equal to D. That is a condition for symmetry. Okay. So symmetry and reciprocity. So I hope